Okay, I think we can start now. So, good morning. My name is Rachit Verma, and today we are going to be holding week 2 of the problem solving session for Foundations of Cloud IoT Edge ML. The instructor for this course is Professor Rajiv Mishra. I'll be serving as the TA. Just a little bit about me. I'm a PhD student in IIT Dharwad in the computer science department, and I have worked on cloud computing for the duration of my master's and my bachelor's. So, I will be beginning now. Okay. So, I hope the screen is visible and I am clearly audible to all of you.
Yes.
Okay. Thank you.
Hello all.
Hello.
Good afternoon.
Good afternoon. So, I'll be going over over the contents of this session first. So, before we begin, uh, I'll be going over how we'll be going about this session. So first I'll be going over a short summary of whatever was discussed in the first two lectures. Then I'll be going over some assignment questions that were discussed the last time this course was offered. And after that, I'll be going over some problem statements that I have formulated for you all to gain a deeper understanding of the subject matter. And I'm sorry, just a second. So I would recommend that all of you turn your videos off, because a recording of this session will be uploaded to YouTube. So if you're not comfortable with your video being visible on YouTube, or your voice, so please take the necessary steps. And okay, so let's begin. So in the first lecture, we discussed the components of the IoT platform. We had discussed how data would be ingested from what different types of devices actually generate data, how they would be ingested, and we discussed cloud IoT, that section of the IoT architecture. We then discussed the various ways in which you could do stream analytics. We then discussed the various ways in which you could process the incoming data. We also discussed we then also discussed how this data could be presented, and we discussed the various layers that are responsible for carrying all these tasks out. And then we went on to discuss, and in addition to this, we discussed the various items in the Azure platform that allowed all of these things to happen. And we discussed the MQTT protocol, not in depth but in some surface level. And yes, and then we went on to discuss time and clock synchronization. We discussed the necessity for time and clock synchronization, and before that we also discussed how discussed the various scenarios in which time was kept. We discussed the pitfalls of what would happen if clocks across devices were not synchronized. We saw that correctness and fairness are important considerations while managing time. And then we saw several algorithms. We saw several algorithms that were used for time and clock synchronization. So we saw the Christian algorithm, we saw the network time protocol, we saw Berkeley's algorithm, we saw the Lampert's timestamp ordering system, we saw the vector timestamp, we saw the yes, I think we saw all these. And then we had also discussed what clock skew and clock drift were, and we had also discussed how frequently you have to synchronize clocks if you are in an asynchronous system. Yes. Sorry. Okay. So I hope this summary is clear to all of you, and I think I can now be going on to discuss the MCQs and the problem statements that I have for you. So so the first 10 questions actually come from the assignments given last year, and I have modified them a little bit so as not to interfere with the assignments that have already been provided to you. Okay, so the first question is, in an IoT platform, things send data or events that are used to generate actions. This statement is true or false. Now when I say true or false, I'm looking for precision, right? So even if this statement does not encapsulate the entire story, then it would be false. Okay. So does anyone have any responses?
True.
Okay. Murugan Gopal says it's false. So this answer is false because things send data or events that are used to generate insights, right? These insights, if they are actionable, only then you perform actions based on them. Okay, so that is the entire story. So this story is incomplete. So that is why this statement is false. Also, thanks for trying. So which Azure service is used for managing devices and for putting certificates on devices? Is it the IoT Hub? Is it B, IoT Central? Is it C, the Azure Digital Twin? So does anyone have any responses?
Hub A.
Yeah.
IoT Hub.
Yes. So IoT Hub is the right answer. Just a second. I had a call coming up. Okay, so IoT Hub is the right answer. So Azure Digital Twin is someone has mentioned IoT Azure Digital Twin. So Azure Digital Twin is used to replicate the device management. Is used to replicate the state of the device and place it on one of the IoT cloud services. So it is not it's not the most accurate answer if you consider the slides. Okay, so dash is data to process in real time within a long time of the happening, and then it is presented to the consumption layer. Is it A, hot part data, B, cold part data, or C, warm part data?
Hot path data.
Hot path, but
Hot path data.
sorry,
Option E.
hot part data. So I want you to pay very clear attention. Oh, okay. I'm sorry. There's a small typo in the question. Dash is data to process in real time. This real time word should not be there. Okay. Dash is data to process within a long time of the happening. Then it is presented to the consumption layer. Okay. Now can you all repeat your answers? Just neglect this real time. Just consider this long time.
Cold.
Yeah. So that is correct. So hot part data is data which is processed completely in real time. And cold part data. So the data is stored, and then there's a timer that is used to trigger the processing of the data. And warm part data is in which the duration of the processing is much lower than the cold part. So it is somewhere in between hot and warm part. So let's go to question 4. So dash is used for batch style oriented workloads and can be used for streaming.
Option B.
B.
Yeah, that is true. So A, event hub, B, Databricks, or C, Kafka. So Kafka is used primarily for streaming. So Databricks, that is true, it is primarily used for batch style workloads. However, you can like reuse it for streaming purposes also. So yes, so that is the correct answer, the Databricks. And event hub is also like primarily used for like streaming purposes. I mean, it's used for like data streaming. Okay. So the next one second. So dash is batch oriented processing that processes the messages as they accumulate on the system, and then trigger, and then on a trigger take the data that has been accumulated and process that data in a batch. Is it A, hot path, B, warm path, or C, cold path?
Cold.
So yes, so cold. Does anyone else have any other responses?
Warm path.
Warm. Okay, so cold path would be the most intuitive answer in this case, but over here we have not specified any durations, right? So wherever there is some amount of batch processing, you could say even warm path fits in there. See, we have not said it has to be a very long time. So even like 15 or 20 minutes, 15 or 20 minutes would satisfy. Just a second. I'm getting some calls. Okay. So so in that case, so B or C would be the right answer. Someone has said A as well, so that wouldn't be acceptable over here because it is batch oriented processing. So edge computing refers to the computations that take place at the inside edge of the internet. So is this true or false? Okay, so I don't have any responses. Okay, some people are saying B and or A.
True.
Okay, so the edge computing does not have, so it's not necessarily associated with the internet, right? So within any network, so it could be like if you have your cloud need not necessarily always be associated with the internet. You could form the cloud and the edge in its own like separate network itself. So if you take that into consideration, it is actually false, right? So it need not always be the internet. It can be like any network. Okay. So in the synchronous system, model consensus is not solvable, whereas in the asynchronous system, model consensus is possible to solve. Is it A, true, or B, false? Anyone has any responses? Okay, so I have two responses. So SK Praveen says true, Murugan Gopal says A, sorry B. So Murugan Gopal's answer is B. So what do we mean by consensus, right? So consensus means can everyone agree on a certain result, right? So in the synchronous system, what happens? All the clocks are properly synchronized, but in the asynchronous system, the clocks are not properly synchronized. So in this case, so in the asynchronous system, what will happen is, since the clocks are not synchronized, you could have a problems with correctness and fairness. So because of that, it is not always possible to solve consensus. So what will then happen is, because it's not possible to have consensus, model consensus is not, consensus is not possible to solve in the asynchronous system. And in the synchronous system, since the clocks are all properly synchronized, we can say that consensus is solvable, because correctness and fairness is not necessarily an issue. So in that case, the answer to 7 is false, right? Because in synchronous it is solvable, and in asynchronous it is not solvable. Okay. So in dash, a channel acts like a set in which the sender process adds messages and the receiver process removes messages from it in the order that the message that is entered first leaves first. So is it A, non-FIFO model, or B, FIFO model? Okay, so do I have any response?
It's a B, FIFO model.
Okay, fine, good. So 3 people have responded. So Dev, Murugan, Gopal, and one more person. So all of them have said FIFO model. So FIFO model is the correct answer. So for those of you who don't know, FIFO stands for first in, first out, right? So and another model is last in, first out, and let's say, and you can also assign priorities in other ways, such as using priority queues. Okay. So over here the comparison is between first in, first out and non-first in, first out. So what happens in first in, first out is an item enters the data structure, and let's say someone is looking to retrieve an item from the data structure. The one that is entered first leaves first, and the opposite of that would be last in, first out, which is like a stack. So whatever enters first leaves last. So the correct answer to this question is the FIFO model. Okay. So event A has a Lampert timestamp of 4. Event B has a Lampert timestamp of 8. What can we tell about events A and B? Event A and B are causally related. Events A and B are concurrent. Event A happened before event B. Or if events A and B are causally related, then event A happened before event B.
D.
Okay. Any other responses?
D.
That says D.
D. Okay. Some people, Murugan Gopal says C. Okay. So let's go through the options. So if we have the Lampert timestamps, of 2 processes, there is no real unless this information has been already given to us, we cannot say that. So we cannot say for sure that the event is causally related. Okay. So so we cannot say for sure, like beforehand only, that the event is causally related. So unless that information is given to us, we cannot say that an event is causally related. And as far as B is concerned, so events A and B are concurrent. That information is also not given to us. So of course, like if you have just been given the Lampert timestamp, the events can be either causally related, or they can be concurrent, or there can be like no clear relationship like between each of them. Okay. So concurrent means the processes are taking place in parallel. Okay. In a certain processor. So because you cannot say it's causally related, you cannot even argue that C is the correct answer, because you cannot say that event A happened before event B. So in D, what is happening is that this information is being specified, that we are getting to know that events A and B are causally related. So if they are causally related, and if one event A has a lesser timestamp than the other event, then we can say that that event happened before that other event. So A has a lesser timestamp than B, therefore event A happened before B. Okay, so let's go to the 10th one. So dash is the relative difference in clock values of 2 processes, and dash is the relative difference in the clock frequencies of 2 processes. With A, clock skew, clock drift; B, clock skew timestamp; C, timestamp clock drift; or D, clock drift and clock skew. Any responses? Okay.
Option A.
Option A. Okay. Any other responses? Rajesh Kumar also says option A. Okay. Relative difference in the clock values of two processes, and dash is the relative difference in clock. Okay, so the answers are coming in quickly. Okay, fine. So three
Option
of you.
A.
Fine. Option A. So a lot of you have said option A. So the relative difference in clock values of two processes is the clock skew. The relative difference in the clock frequencies of the two processes is called the clock drift. So we had in the slides we had discussed this with the example of considering a car moving. So if two cars have so like the difference in the distance between the two cars, you could say is the clock skew, but the difference in the speed between the two cars is called the clock drift. So in that sense, A is the correct answer, clock skew and clock drift. So now I'll be going over the questions from the some MCQs that I have prepared for you based on the first lecture, Introduction to IoT Platform. So question 11, what is the specific role of sensors and actuators within the IoT platform as mentioned in the information provided? Is it A, sending data and generating insights? And is it B, facilitating device communication? And C, handling cloud storage? Or D, running machine learning models?
D, running machine learning models.
So any other option?
A.
Okay, fine.
A.
Okay, fine. Good. So A is the correct answer. So sensors and actuators in the IoT platform, these are called things. So what they do is they generate data. They generate data. And this data is sent to the cloud IoT for handling the device messaging, and this is then sent via the hot path, cold path, or the warm path, and then this is consumed, right? So whatever insight is generated through the hot path, warm path, and the cold path, so that is then consumed by the consumption layer. So I will admit I made a small mistake over here. So the sensors and actuators, they themselves don't generate any insights. Okay. So they themselves don't generate any insights. So that is done at the cloud, the processing side. And the facilitation of device communication is not handled by the sensors and actuators themselves. That is handled by cloud IoT. And as far as handling cloud storage is concerned, sensors and actuators don't handle the cloud storage, of course. That is handled by the cloud. And someone had answered machine learning models. The sensors and actuators aren't exactly capable of running machine learning models. That is generally done at the edge side or the cloud side. The sensors and actuators, if they are connected to a microcontroller, then there is some possibility of running machine learning models. However, generally these microcontrollers are also not powerful enough to run significantly powerful machine learning models. So I hope it is clear. So what does the uncovering of events within sensor data lead to, as mentioned in the information provided? Is it A, real-time queries? Is it B, data processing? Is it C, generating actions? Or is it D, cloud storage requests?
C.
C. Any other responses?
Data processing.
Any other?
Data processing.
Data processing. Okay, so let's go through the options. So C is the correct answer. So what is this uncovering of events, right? So this uncovering of events is what happens at the insights layer, right? Is what happens at the insight section. So an uncovering of events is the equivalent of generating an insight. So an insight is generated after the data has already been processed, right? So after the data has been processed, you generate an insight. Then this insight, then after all this is based on this insight, some action is taken by the consumption layer, right? So generating actions is the correct answer, and A, real-time queries. All this happens before cloud storage requests. This may happen in the process of uncovering events, but after but what it exactly leads to is the generation of actions. Okay. According to the information, what are the three different components categorized in an IoT application? Is it data source, intelligent tier, actionable insights, things?
Option A. Option A.
Okay, just a second. Is it B?
B.
Things, insights, actions? Is C, data processing, real-time queries and stream processing? Or is it D, things, cloud storage and machine learning models? Okay, so some of you have said B, one person has said A. So the correct answer is B. So if you look at A, right? So A is actually the answer to the edge computing layers. Right? So if you look at the three-tier architecture in edge computing, so there's a data source, there's an intelligent tier, there's an actionable insights. So IoT platform also follows a similar architecture as edge computing, but as edge computing. However, the architecture is a little different as compared to edge computing. However, the fundamental building blocks of it are things, insights, and actions. The things generate data. Insights are what you gather from the data, and based on those insights, you take some actions. And as far as C and D are concerned, C is data processing, real-time queries, and stream processing. So these aren't actually happening in order, right? So after do these aren't necessarily what is happening in order. And things, cloud storage, and machine learning models. This is also the wrong answer, because an IoT platform requires these are you could say components that could come within one of the three, like things, insights, actions. These themselves alone won't be able to encapsulate the entire architecture of the IoT platform, because see, there is no option to perform actions in D. Right? So even in C, all these three options, right? These will most likely fall under one of things, insights, and actions. Okay. So in a manufacturing plant, what type of data might a milling machine send, including feed rate and temperature, as mentioned in the example? Is it A, cloud storage requests? Is it B, machine learning models? Is it C, real-time queries? Or is it D, sensor data?
B.
It's a real-time query. C.
C? Real-time queries?
D.
Yes, C.
D.
Okay, so I believe the question needs to be parsed properly to get an answer. So in a manufacturing plant, what type of data might a milling machine send, right? So a milling machine is not capable of performing real-time queries, right? So that is performed by some sort of computer or some sort of server or some
D,
device.
sir. Option D.
Yes. So D is the correct answer, sensor data. So I just want to go over the options. So a milling machine cannot make cloud storage requests directly, right? So that the cloud storage request will be performed by one of the components in the IoT on the cloud side. So after you send the data, right? So maybe perhaps the cloud IoT hub, perhaps the cloud IoT will handle this. And so sensor data is the correct answer. So the milling machine will have some sort of sensor data such as feed rate and temperature. All of this data will be sent as a stream to the cloud for processing. Okay. So how can the data sent by machines in a manufacturing plant used to evaluate their operational status? Right. So is it through one second. So is it through A, running machine learning models, B, performing real-time queries, C, generating actions, or D, uncovering events? Please think about this carefully. Is it A, running machine learning models, B, C, generating actions, or D, uncovering events?
C. Generating action.
Okay. Perhaps the
B.
question. Okay, so perhaps the question is not fully clear. I think I'll rephrase the question a little bit. So how can the data sent by machines, like what can you do to the data to evaluate the operational status? That is my real question. What can you do to the data to evaluate the operational status? So is it
ML models.
okay? Okay. So that is also a fair answer. So some of you said run machine learning models. Is it B, perform real-time queries, C, generating actions, or D, uncovering events? So if you can, so if you want to, so you can perform, you can run machine learning. So you can see this as multi-correct too. So
A and D. A and D. Uncovering.
Option A, sir.
A and D.
okay. So in my opinion, if you ask me, the answer is A and B. Okay. So so yes, so you would require you would require uncovering events. So that is the final goal. But how would you, what would you do to the data? Right? You can either perform a machine learning model, or you can perform real-time queries on it. Right? So like the eventual result of that would be you would uncover an event in that. Right? But what you would actually do do to the data is you would run a machine learning model, or you would perform real-time queries on it. Okay. So I hope that is clear. So of course only after you do this, then you can, after you evaluated the operational status, then you can generate some sort of action. But before you do this, you need to analyze the data, and that happens through performing either real-time queries or through running machine learning models.
So the answer is A and D, right?
A and B.
Okay.
Okay. Okay, fine. Let's go to the next question. So according to the example provided, what becomes an insight when evaluating the data from a machine in a manufacturing plant? Is it A, real-time queries, B, sensor data, C, whether the machine is running or not, or D, feed rate and temperature data?
C. Whether machine or running on.
Okay. Yes. So that is the correct answer. I believe something else was said in the lectures. You may want to check that. I have some problem with that. Like in the lecture, something indirectly was said that feed rate and temperature data would be an insight. But if you ask me personally, my opinion, it is C, whether the machine is running or not. Or I may have parsed the lecture incorrectly. So okay.
Feed rate is input to that, but the insight is whether machine is running or.
Yeah. Yes, that is my reasoning as well. But I just want to recheck with the lectures what exactly is said. See, because feed rate also, right? You may actually take in when the feeding is happening, and then you may calculate the feed rate from from
Okay,
how
if
frequently.
feed rate is not taken as input, then it may become the answer.
Yeah.
Means if we are processing other data to get the feed rate, then it's means other sensor data to get the feed rate, then it can become an insight.
Yeah, that would be a logical way to think about it. So, okay, fine. So it's not A, real-time queries, because so it's not A, real-time queries. It's not B, sensor data, because this is what you use to generate the insight. And then whether the machine is running or not is what the insight will give you. So for example, if the temperature is much lower and very low for a very long period of time, means the machine is not hot, so it probably means that it is not running. And feed rate and temperature data is the actual sensor data that we use to figure out whether the machine is running or not. So what is the term used for the evaluation of data from machines in a manufacturing plant to determine their operational status? So we have just looked at this.
Insight.
Hmm. Right. So that is it. Is the previous question restated in a different manner? So is it A action, B real time queries, C in uncovering events, or D insight? The answer is D insight. So that would be the most that would be the most precise that would be the most precise answer. So uncovering events is also a process of deriving insights. That is only a process, and A and B have nothing to do with. I mean, of course, they don't directly have something to do with insights. Real-time queries may be used to generate insights, and action is what you would perform after you gain an insight into something. So in the manufacturing plant example, what is the purpose of using insights generated from machine data? Is it A, running machine learning models? Is it B, uncovering?
Optimizing plant.
Yes.
Operation.
Yes. So wait, so I'll just read out the options and then, or is it C, performing real-time queries? D, optimizing the plant operations? So two people saying D. Any other responses?
Option C.
Option C. What? Okay. So we have D and C as options. So now we want to look at a purpose, right? So the purpose of using insights. So that is, so when we ask what is the purpose of something, we are looking at what is the end goal of performing a certain action. For example, if I say what is the purpose of walking? It is to, let's say, go to the next room, right? So the purpose of walking is not to move your leg forward or backwards, right? The purpose of walking is to go to the next room. So in that sense, if we look at this question, so the purpose of using insights, so what is the goal of using those insights? So it is we want to use those insights to optimize the plant operations. So in order to obtain these insights, okay, we may perform real-time queries, we may uncover some events, and we may run machine learning models or something along those lines. Okay, so in that sense, D is the correct answer. So according to the information provided, what term is used for the purpose of, oh, I'm sorry, I think this is a repeat question. Okay, so in the context of a manufacturing plant, what is the term used for the decision making processes based on the insights generated from the condition of machines? Is it A, real time queries? Is it B, business intelligence? C, machine learning models? Or D, cloud storage? Okay, any other responses? Okay, so I'm getting B and C as answers. So the decision making process, right? So the entire decision making process, right? So machine learning may only be like a small part of it. Okay, we may even use heuristics instead of machine learning models, or we may even, machine learning is not the only way of generating insights from data, right? So there are many statistical techniques that have that can be used to generate these insights. So okay, so basically, so there are two options, so B and C, that there is some kind of confusion over. So there is this entire decision making process, right? So the term used for that is called business intelligence. Okay, so in order to facilitate business intelligence, you may be using machine learning models, you may be doing real-time queries, and you may be using some data from the cloud storage. Okay, so in that sense, even when you're, let's say, working on the web, right, and you generate some insights from, let's say, from some sort of user data, so that entire thing is called business intelligence. So according to the information provided, what type of information does the data generated by things in an IoT platform contain? Is it cloud storage, B, real-time queries, C, actionable insights, or D, machine learning models? Okay, so I have two responses over here. Sorry?
C.
C. Okay. Fine. So there's confusion between real-time queries and actionable insights. I believe Rajesh Kumar wrote B right now. So real-time queries are not really so the data cannot really contain a query, right? So it's only the architecture, like the data, unless someone is trying to attack the system, right? The data itself may not have a query. It's only the final device that you're sending the data to that wants to actually generate an insight from the data. Only that may actually contain a query that can be used to generate some sort of actionable insight. So in that sense, the correct answer is C, actionable insights, and it's not D, machine learning models. It's not D, machine learning model, because the data, of course, you cannot. It's not always true that these sensors are sending machine learning models themselves. But they're not capable of that. And cloud storage is not data. By the way, if you work in federated learning, you will see that like the complete you will see that people will be sending the weights of a model directly. So that's actually something very interesting to explore. So in an IoT platform, what component is responsible for processing the information generated by sensor for making decisions or taking actions? Is it A, cloud analytics, B, real-time queries, C, cloud IoT, or D, cloud storage? Okay, so between B and C, there is some confusion. So between real-time queries and cloud IoT. So which of these are components of the IoT platform, right? Even if you just think about that, you will probably, like directly in the slides, which of these have been seen to be components of the IoT platform. So cloud analytics, even it is not a direct component. It may be part of maybe one of the paths, right? Hot storage, hot path, warm path, cold path. But it is not a component of the IoT platform directly. And B, real-time queries, that is not a component either. Cloud IoT is a component. D, cloud storage, once again, it is not a component directly. It could be present in one of the paths, hot path, warm path, or cold path. So in that, if you just do that analysis, you'll see that C, cloud IoT is the right answer. And even then, if you take a look at the slides, so the cloud IoT is responsible for like taking in the is responsible for this kind of processing the information. So please correct me if I made any mistakes over here. So in the pre-processing path of data in an IoT platform, what component is responsible for presenting insights derived from the information generated by the sensors? So is it A, real-time queries, B, cloud analytics, C, cloud IoT, and D, data presentation? Wait, in the previous question I may have made a small mistake. The cloud IoT is not necessarily responsible for processing the information. It just handles the device communication. Okay, so sorry, there might be a mistake here. Anyway, I'll just check that and let you know. Okay, but let's look at this 23rd one. In the processing of data, in the processing path of data in an IoT platform, what component is responsible for presenting insights derived from the information generated by the sensors? Is it A, real-time queries, B, cloud analytics, C, cloud IoT, or D, data presentation? Okay,
B.
B. Okay, so some of you are saying B. 2 people have said B. So over here, the keyword in this question is presenting insights, right? So cloud analytics is the analytics part, like that is the kind of processing you do on the data, and to generate some sort of insights. After the insight has been generated, you want to present this insight, right? So where does this happen? So of course the cloud IoT happens a lot. This cloud IoT is not the right answer because this takes place before the data is being processed. Real-time queries may be used for generation of insights. Okay, so it is not exactly a component directly of the IoT platform, and the correct answer would be a D, data presentation. Right. So D is the correct answer. So question 24, what is the final step in the IoT platform where consumers use insights and take actions based on the processed data? So once again, this is a repeat of the previous one, but I think you'll be able to answer this. Yes, see, it's presentation of insights. So what term is used for entities who come to take actions based on the insights present in an IoT platform? So is it A, edge devices? Is it B, data analytics? Is it C, cloud IoT? Or is it D, consumers? Okay, so it's any other? Okay, so C and D. Okay, so a lot of you are saying D. So yes, so D is the correct answer. So after the insights have been generated, right, so you now need to perform some kind of action. This action could be, let's say, turn the machine off or turn the machine on, or increase the temperature, decrease the temperature. So the devices that actually go in and use these insights for their tasks. So this is done by the consumer. Okay, so all these devices, the term consumer actually captures the essence of all these devices. So cloud IoT happens happens before the processing and before the insight has been generated. Data analytics happens during data analytics is used to generate the insights, and edge devices, of course, they're also there, but they're not really the consumers directly, right? They exist to reduce the round trip time between the device and the cloud. So edge devices could facilitate this communication between the cloud, but they are not consumers directly. In the lecture, what term is used to describe the deployment of sensors and automation devices at the machine or factory level or in a smart city? Is it real time? This is a simple question. So real time queries, cloud storage, things, or edge devices? Okay. So yes, so C, things is the correct answer. Okay. Just a second. Please don't come in. Yes. So see, things is the correct answer. 2 of you have answered it. So real time queries, of course, it is not the correct answer. I just frequently put it in here. And cloud storage are not devices. Now it could be possible to be confused between things and edge devices. So edge devices is like one layer above this sensors and automation, right? So they could do some sort of generation of insights, and so they generally have more processing power than these sensors and automation devices, and they're more specialized towards doing some sort of computation and processing. Okay. So what is Azure Sphere? Is it a cloud storage service? Is it a lightweight operating system? Is it a virtualization? One second. Okay, so is it cloud storage, lightweight operating system, virtualization platform, or is it deep machine learning model? Anyone has any answers? Multi-correct. Hello, is anyone there? Okay, so the answer is it is a lightweight operating system, and that would be the most accurate answer. And while it does allow, you could also call it a virtualization platform. You could also call it a virtualization platform to some extent. So in that sense, it would be somewhat correct. Based on the contents of the lecture, you could kind of infer that it is a virtualization platform. However, the most accurate answer is that it's a lightweight operating system. And a cloud storage service, it's not a storage service and it's not a machine learning model either. So what is one of the main capabilities of Azure Sphere on a device? Is it A, running complex analytics? Is it B, creating a virtual device? Is it C, providing cloud storage? Or is it D, running a traditional operating system? Okay, so they have said B. Any other responses? B, B, B. Okay, yes. So that is the correct answer. So Azure Sphere. So Azure Sphere is primarily responsible for creating a virtual device. So it will not exactly run a traditional operating system because it is because an IoT device cannot handle a traditional operating system like Windows. It requires these kind of embedded operating systems. So these embedded operating systems also tend to be lightweight, so as to take care of these sensors, and so as to take care of the needs of these IoT devices. They doesn't exactly provide cloud storage. That wouldn't be the exact answer. And complex analytics is not really its purpose. That would be, you could say Kafka or something like that would be handling that. So which of the following is a feature of Azure Sphere? Okay, is it A, heavyweight operating system? Is it B, lack of device connectivity? Is it C, device security through a specialized operating system? Or is it D, exclusively for machine learning models?
C.
C? Okay, fine. So yeah, so C is the correct answer. Let's go with the other options. So it is not heavyweight operating system because, as we had just mentioned, Azure it has to run on these smaller devices, so it cannot do any kind of heavyweight processing. And lack of device connectivity, that's not true again. You can if you have Azure Sphere involved, you can connect to the cloud and things like that. It does enable device security though. So as was mentioned in the lecture, it's not exclusively for machine learning models. You can do things other than machine learning models in it as well. Okay. So which software is described as a specialized SDK for interacting with various devices? Azure Sphere, Cloud IoT, Azure IoT SDK, and IoT Stack. So I think Dev has said C. Any other responses? Murugan Gopal has also said C.
Azure, sir. Azure Sphere.
Sorry?
Azure Sphere.
No. No. Okay. So Selvi ma'am has said the answer is A, Azure Sphere. So I'm looking for a specialized software development kit. So Azure Sphere is a lightweight OS, right? So it is not exactly a software development kit. So an OS, an operating system, it contains code for you to an environment for you to run applications. But in order to create the applications, you need something called a software development kit, right? So which one? So I mean, in order to create these kind of interactions with various services, so which of these options is true? A lot of you have said C, Azure IoT SDK. So that is the correct answer. And Cloud IoT is not exactly the right answer, because it is general across the IoT platform. Okay, it is not an SDK. IoT stack is, of course, that's the entire stack. Things, insights, actions, contains devices, everything. That is the wrong answer. So in the context of an IoT platform, what does cloud IoT manage in the IoT stack? Hit A, unlimited cloud storage. B, devices and device messages. C, running complex analytics. Or D, creating virtual devices. So, okay, so there's some confusion between B, D and C. Okay, wait, let me see if I can. Okay, so the complex analytics part, so that complex analytics part is not exactly run by cloud IoT, right? The cloud IoT does the device managing, it does the device brokering, device provisioning, it does the it allows you to message between two devices. But after that, the hot path, warm path, and the cold path, right? It is these so it is these components that actually handle the processing of the data. So if I'm wrong, please let me know. So this was what I understood from the lecture, and the most accurate answer. So the most. So the most accurate answer in this case would be device and device messages. So the cloud IoT may not necessarily always create virtual devices. So that depends on the platform, right? So Azure may allow for some sort of creation of virtual devices, but it is not necessarily true across every kind of IoT platform. And device provisioning and device messages would be the most accurate answer. Okay, so of these four options, right? So what is the function of cloud IoT in the IoT platform based on whatever you have learned in the lectures, right? Does it provide cloud storage? Does it ensure device security? Does it send commands to devices, or does it run machine learning models? Any responses? Okay, so I think ensuring device security and sending commands to devices. Yes, so you could say that these are somewhat accurate answers. Although sending commands to devices, I don't think this was very clearly discussed in your lectures. So the most accurate answer would be ensuring device security. So you could say it device to device, some sort of communication happens. B would be the most accurate answer. It does not exactly provide cloud storage either. That happens later after the messages have been received.
I had a question, like what is device provisioning? Like it is part of cloud IoT, but it was written use cases device provisioning. What is device provisioning?
Well, it is you could say, so I'm also not entirely clear about this, so this probably could differ among various cloud services. So so one thing is, let's say you have like an IoT hub, right, and you want to like connect some devices to it. I think that would kind of fall under the category of device provisioning.
Connecting to the device.
Yeah,
the IoT sensor.
Yeah, like that would be like one way to think about it, but yeah, like to some extent, like you are allowing them to exist on your platform.
Okay, got it.
Okay, I think that would be a good way to describe it. Okay, I will get back to you on this question. Okay,
Okay.
fine. So, which protocol is used by cloud IoT to transfer messages between devices and the cloud in the IoT platform? Azure SDK, MQTT.
MQTT.
Yeah, yeah. So this is somewhat like straightforward. Um, so this is somewhat straightforward. So cloud IoT, you could say, is the platform, but the protocol, the other three aren't exactly protocols. Cloud IoT, Azure Sphere, and Azure SDK. MQTT is the only protocol. So MQTT is the correct answer. So what service does MQTT provide in the IoT platform to transfer messages to the cloud? Is it A, Azure SDK? Is it B, device provisioning? C, cloud IoT? D, message broker?
Message broker.
Okay. Any other options? Okay, fine. So yeah, so message broker is the correct answer. So MQTT is for communication, right? So the other three aren't services at all besides device provisioning. Okay. So what functionalities does cloud IoT provide in the IoT platform? Is it A, device provisioning? A, device provisioning, ensuring device security and creating a virtual device. Uh, B, device security, machine learning, cloud storage. C, brokering messages, device provisioning, ensuring device security. D, cloud storage, virtualization, and MQTT support.
C.
35? Yeah, yeah.
C.
C, yeah. So C is the right answer because C, so now if we look at the options, right, there could be some confusion between C and A. So it is not necessary that the cloud IoT will always help you create a virtual device. Okay. So device provisioning and ensuring device security. So this will, so these two are most likely are almost guaranteed, and the third thing that it does is it helps broker messages between two devices, and the other two options, device security, machine learning, and cloud storage. So if we look at these, of course, it does not necessarily do the other two, and even then those two are like sub-components of some major component. And okay, what does MQTT stand for in the context of machine-to-machine communication? Message.
Option D.
Okay. So message queuing, telecommunication transport, query telemetry transport, mapped query transport technology. D, message queuing, telemetry transport. So okay. So yes, so the answer is D, message queuing, telemetry transport. So this does not require any huge reasoning. You just need to know the answer to the question. And so okay, so it's not exactly telecommunication between two devices. That's one way to rule out the first option. And okay, so in IoT communication, what type of system does MQTT operate as for transmitting data between devices and the cloud? Is it A, a point-to-point system? Is it B, a publish-subscribe system? And C, peer-to-peer? Or D, cloud-centric? The most accurate answer.
Option D.
Option D. Any other? See, in order to transmit data between devices and the cloud, right? Like how is it facilitating that? See, cloud-centric is already there in the question, right? So there's a very specific term that was discussed in the lectures. I hope you remember that. Okay, so so there's options that are coming up are A and B, point-to-point system, and B, publish and subscribe system. So the answer is a publish and subscribe system. So this is called a pub/sub, right? The short for publish subscribe is pub/sub. What happens is there's like a resource. So anyone that puts data in it is called a publisher. Anyone that retrieves data from it is called a subscriber. So this system, so MQTT uses this system for allowing communication. So it's much like, let's say you have a newspaper, right? If you let's say write some of your own articles on it, right? You can publish it on the newspaper. Anyone who buys the newspaper is like a consumer of it. So that is the publish and subscribe system that MQTT follows. So why is a management suite required in IoT, especially in scenarios with a large number of deployed devices? Is it A, to limit number of devices? I mean, once again, I'm looking for the most accurate answer. B, to ensure device security. C, to scale devices and provide various services. Or D, to replace the MQTT protocol. Okay, so Murugan Gopal has said B. Any other, do we have any other responses?
C.
C, okay. So to ensure device security only, or to scale devices and provide various services. So now B is not the most accurate answer, because that is not the only thing that the management suite is doing. Right? It is not doing only device security, but its major purpose is to scale devices and provide services. Right? So that is what the management suite is intending to do. It is not trying to replace the MQTT protocol. In fact, it is encapsulated within it, and it is not trying to limit the number of devices. In extreme cases it can happen, but that is not its major purpose. Okay, that is not why it is required exactly. We want to increase the number of devices as much as possible. So how does Azure IoT Central contribute to the scalability of IoT applications on Azure? Is it A, by providing edge computing services, offering device security, by supporting multi-tenancy with different devices, or D, by encapsulating machine learning models? Yes, C, by supporting multi-tenancy with different devices. Any other options? Okay, fine. So a lot of you are saying that C is the correct answer. Yes, that is true. C is definitely the correct answer, and it does not. B would be the wrong answer, because it does not only provide device security, and Azure IoT Center is not exactly for edge computing. It's for handling the IoT devices, and as far as encapsulating machine learning model is concerned, that is not its primary purpose. Its primary purpose is to handle these IoT applications. So Azure IoT Central, so is it edge computing service, platform as a service, software as a service, infrastructure as a service? Any responses?
Option C.
B.
B.
No. So Azure IoT Central is a software as a service, right? So there's another platform as a service. I think that was discussed. So it is not this one. So Azure IoT Central is a software as a service. So what is the primary purpose of Azure IoT Central in the context of IoT applications? Is it device communication with the cloud, scalability of edge computing services, encapsulation of machine learning models, or creation of applications with the encapsulation of functionality? Okay, so I'm getting D as the options. Any other options? Are there any other responses? Okay, fine. So I will go with D. I will go with, so yes, so D is the correct answer over here. So Azure IoT Central allows you to create applications while keeping the functionality encapsulated. Just a second. Okay, fine. I'm sorry, just had something come up. So encapsulation of functionality. So what role does Azure IoT Hub play in managing IoT devices on the Azure platform? Is it edge computing, device provisioning and management, multi-tenancy support, or encapsulation of functionality? Any responses? Okay. Yes, so B is the correct answer. It allows for device provisioning and management. So that is its main purpose. You have something to say? How is device configuration facilitated in the Azure IoT Hub? Is it through edge computing? Is it through using Azure Digital Twin, or with device provisioning services? And D utilizing machine learning algorithms. Yeah. So yes. Okay. Any other options? Any other options?
So through edge computing?
No. Specifically in the Azure IoT Hub, right?
Okay, sir.
So specifically in the Azure IoT Hub, it is done using Azure Digital Twin. Okay. So basically, a digital twin of the device is maintained in the cloud, and through this, like, device configuration is facilitated. A digital twin is like the exact copy of the state of the device, utilizing machine learning algorithms. So this is not really specified in your lecture. Maybe it does it, but it's not necessarily doing it. It's not necessarily, like, it's not specified in the lecture, so we cannot be sure of this. So what is the primary purpose of Azure Digital Twin in the context of Azure IoT Hub? Okay, so is it A, providing machine learning algorithms, B, managing low level messaging, maintaining a digital twin, ensuring multi-tenancy support? Okay, so many of you have said C. Any other responses? Okay, so C is the correct answer. Okay, so it maintains a digital twin with the device configuration and the state information. So the digital twin, it does not manage something like low level messaging from devices. So that would be something that is handled by cloud IoT. Okay, it does not. So it is not clear whether Azure Digital Twin exactly manages that. And multi-tenancy support is something that is, you could say, handled by the IoT Central or the IoT Hub, if I'm not wrong. And that is not, once again, Digital Twin is more so for managing the configuration and the state information. And Digital Twin definitely, I don't think it provides, I have not worked with Digital Twin, but I'm pretty sure it does not provide any machine learning algorithms for it, because its main purpose is handling the twins, is handling the state information and device configuration.
Oh, what is multi-tenancy support?
Means you have several devices operating at the same time.
Okay.
Wait, we were in 41. like multiple tenants, right, in a house.
Yeah.
Okay, so that. So how does Azure Digital Twin integrate with Azure IoT Hub? So providing machine learning algorithms, device provisioning services, maintaining a digital twin, handling low-level messaging. It's also like a similar question. Any responses? I think some of you have said C, right? Yeah, okay. Any of you have any other responses? Okay, C is the right answer. Sorry, you have something to say? Okay, so C is the right answer. It maintains a digital twin of the device in the cloud. And it does not handle low-level messaging, that is handled by something else. We have discussed this. So what are the three different ways data from devices can be processed in the cloud? Hot path, warm path, cold, hot path, machine learning path, edge computing, hot path, warm path, cold path, low level messaging, edge computing, batch processing, or is it cold path, warm path, and device processing? Any responses?
Option B.
Option B. B and someone said D. Okay, so the answer is option B. Okay, so I think there's some confusion between B and D. So B has all the three paths: hot path, warm path, and cold path. So D does not have the hot path. That is the path. It has device provisioning. Device provisioning is not how data is processed. Okay, so low level messaging, edge computing, and batch processing. Batch processing may be how within hot path, warm path, cold path what is happening, but what exactly it is, but the entire phenomenon is encapsulated within hot path, warm path, and cold path. Which term is used to describe the method of processing data from devices immediately as it arrives? Edge computing, cold path, hot path, or warm path? C hot path. Any other responses? Okay, fine. So yes, so the answer is C, hot path. Cold path and warm path are not the right answers because they do some sort of batch processing. Edge computing is not exactly a method of processing data. It consists of the entire phenomenon of processing data close to the network edge. It could be hot, warm, or cold. It could do either hot, warm, or cold, provided it has the storage capabilities.
So the answer is both, sir, B and C?
No. It is just C, hot path. Immediately,
C.
right? Hot path.
Okay.
So what does the term warm path refer to in the context of processing data from devices in the cloud? Processing data immediately as it arrives, processing data in near real time, storing and processing data periodically, or D, handling low level messaging?
It's a processing data in real time.
Warm path. Oh, you mean B, right?
D. Handling low level message.
Sorry.
B.
Processing data in real time. B.
Near real.
Okay, so we have B and D, right? So Harun sir, do you want to say that the answer is D?
I think it is B. Processing data in real time.
Okay, fine. So yes, so are there any other responses?
A.
Sorry? B? Okay, yes, yes. So, yes, so B is the correct answer. Processing data in near real time. So, if we were processing data in like real time, that would fall under hot path. Okay. So, processing data immediately as it arrives is another way of saying processing data in real time. Right. So, A would fall under the hot path. B would come under processing data in near real time. So, for that, the answer is warm path. And C, storing and processing data periodically. So now here the period has not been exactly told to us, right? So it is safe to assume that it is the cold path over here, and D, handling low level messaging, that is not exactly the function of the hot, warm, or cold path, right? That happens before the processing. So what does the term cold path indicate? Immediately
Storing, processing data periodically.
Any other responses?
B.
Okay, so processing data in near real time, storing and processing data periodically, handling low level messaging. Okay, fine. Okay, it's 4:20. Let's see if we have enough time. Okay, in the context of, yes, so C is the correct answer. So near real time would fall under the warm path. Processing data immediately as it arrives would be real time, so that would fall under the hot path. And handling low level messaging, it does not exactly do that. So how is the hot path data processed in context of analyzing data from devices? In periodic batches, immediately or on the fly, after storing for a
B.
while, or in offline mode? Sorry?
Option B, sir.
D as in the fourth option.
Second option.
Okay. Any other responses?
Sir, can you explain what is batch processing?
Yeah, so what happens in batch processing is, let's say you have a lot of data that is coming in. What happens is let's say one of the devices, one of the cloud servers or edge server, what it will do is it will accumulate the data for some time, right? Let's say for 5 minutes, 10 minutes. After this time is over, it has accumulated a certain set of data. That entire set of data is what we call a batch, right? So after this data has accumulated, right, and after this batch has been accumulated, then we process it. So that is what is called batch processing, right? I hope that is clear.
Yes.
So how is the hot part data processed? Is it in periodic batches, immediately or on the fly, after storing?
It is the answer is B, immediately or on the fly.
Yes, that is the correct answer. So it does not happen in periodic batches because the problem with doing batch processing is it is slower than in real time. Let's say you really want a very fast answer. Let's say you have a self-driving car, you're moving on the road, some pedestrian is coming. If you start doing batch processing, right, it will take some time for the data to accumulate, and then after that it will process. So in that much time the car may have hit the person. So everything has to happen very fast. So in that case you will want to do everything immediately or on the fly. And the option is not D, because if you are offline, then you won't be able to connect to the cloud. Then the hot part is not relevant anymore. Okay, after storing, and we have already explained that. So when is the data typically written to the cold storage in the context of IoT data processing? So before hot path, during real time, after immediate, or after hot path for long-term analysis. Okay, D. Any other options?
I'm confusing between D and A, before hot path processing and after hot path processing for long term. I'm confusing between A and D.
Okay. Fine. Okay, I will explain. So let's say you have data, right? Okay, and if you store it before hot path processing, can you do hot path processing on it? Is it possible? So if you store the data, right, you cannot do hot path processing on it,
Yes.
right? So so that is the main idea, right? So if you store the data, then you cannot do the cold storage, then you cannot do hot path processing on it because it is not immediate anymore. So A is not the right answer. But after you have done the hot path, right? So after you have done the hot path, now let's say you want to do some sort of long-term analysis on it, on the temperature. Let's say you use the hot path to convert data from Fahrenheit to Celsius. Okay, and now after you have done this huge kind of hot path processing, now you want to figure out on average what kind of trends does the what kind of trends does the machine temperature follow. Okay, when exactly does it become very hot, on feeding of which, let's say, raw material. Okay, on feeding of which, what kind of raw material does the machine become very hot. So that kind of analysis will be done in cold storage, right? But before that you want to do some quick processing, that will happen in the hot path. Okay,
Okay.
so after immediate consumption, so that happens later, right? Consumption happens after all the analysis is complete. And okay, and D is the most accurate answer in comparison to B.
Okay. Thank you.
Okay, no problem. So what role does stream analytics play in the hot path processing of IoT data? Is it A, storing outcomes? Is it B, real-time data processing? C, offline storage? Or D, delayed processing? Stream analytics.
TB.
It is D, real-time data processing.
Yeah. Okay. Any other? Just one sec. Okay. Fine. So yes. So B is the correct answer. Any other? Okay. Fine. All of you are saying B. So no need to explain anything. So yes. So storing outcomes for long-term analysis, or B, real-time data processing. The answer is B, real-time data processing. So you can offline storage of data. You won't stream analytics is not used for data storage, it's used for analytics in real time. That is why the word stream. And there's no, we don't really want to intend delays because we want everything to happen very fast. That is why the word stream is in it. Which of the following is typically used for batch style processing but also can be used for streaming?
C.
C. Stream analytics, event hub, Databricks, or Kafka. So yes, so C.
Databricks.
Okay. Yes, so C is the correct answer. So stream analytics and Kafka. So Kafka is a way to do stream analytics. So that way you can eliminate both of them. Both of them will not really do batch style because everything has to happen very fast. So at least even if batch style is possible, it's not really been discussed in the lectures, right? So C, Databricks. What can a combination of Kafka, Databricks, and other tools achieve in the IoT data processing? Batch processing, cold storage, hot path aggregation, transformation, queries and filters, and warm path.
Batch processing.
Batch processing? Most accurate answer?
Hot path aggregation.
But I think the answer should be
Yeah.
C.
Okay.
Hot path aggregation, transformation, queries, and then filters. I think C.
Yeah. Okay. So yeah, so C is the most accurate answer. So combination of Kafka and Databricks, right? So these tools put together would be used for stream analytics, right? So stream analytics will follow the hot path, right? And in that you can do real-time queries, you can do real-time filtering and all these things. So in that way, see, hot path aggregation, transformation, queries and filters would fall there. And batch processing, so even though Databricks can do batch processing, but over here, if you look at the combination, right, Kafka, Stream Analytics, Databricks, like these two would be responsible for, see. So what is the term for the processing of accumulated messages triggered by a timer in the IoT context? So
Batch.
yes. So someone here was asking, no, what is batch processing? So answer is here: hot path processing, cold storage, batch, warm path. Any other options? Okay, fine. So see, the answer is batch processing. Let's go to the next one. Which storage option is typically used for batch-oriented processing of accumulated data in the IoT context? A. Data lake, B. Event hub, C. Kafka, D. Stream analytics.
Data lake.
Yeah. Any other options?
Data lake, sir.
Data lake. Okay. So that is any other. Okay, fine. So two of you have said data lake. So the other three: Event hub, Kafka, Stream analytics. Hey, someone has said C. They. Okay, it's okay. So I'll explain why C is not the correct answer. Kafka is used for stream analytics, right? So that is why it is not the correct answer. Data lakes is the correct answer. One minute. So like what I want is typically, right? So Kafka's like major purpose is batch is stream analytics. So even if it is possible, it has not been discussed in the lecture, so I won't be considering that. What is the processing path that lies between the hot path and the cold path, sharing similarities with both real-time data processing and batch-oriented processing?
Warm path.
Yeah, warm path. And is there any confusion in this question? Okay, so yes, so the answer is C, warm path, because warm path, it's not exactly like in cold path the durations are much longer, and warm path could be 5 minutes, 10 minutes, 15 minutes. Cold path duration, hot path durations are like very immediate and quickly, and there's no such thing as batch path. So which tools are wait, I think let's skip this, we don't have time. What is the in the context? Okay, let's do this one maybe. Okay, so what is the primary purpose of aggregating, enhancing and filtering data collected from IoT layer? Store data, speed up data consumption by applications and reports, and encrypt and secure data. Okay, yes. So 56.
The answer is B, sir.
Speed up the data ingestion process. So just to be clear, so when do these things happen? Aggregation, enhancement and filtering, right? When do these things happen? So these happen after the data has been ingested, right? So before the data ingestion has happened, it is not possible to do any aggregation, enhancing or filtering, right? So I'm looking for the primary purpose over here.
C, sir.
Sorry? C.
Option C.
As in, sorry, in C, right?
Yes, sir, C.
Okay. I'm sorry, the voice was not fully clear. So yes, so the answer is C, to prepare data for consumption by applications and reports. That is the correct answer. And encryption and security would happen if two devices are communicating with each other. But once the data is stored, we may not keep them in an encrypted manner. So what role do APIs play in the data collected from the IoT layer? Is it A, they contribute to the cold path processing, enhance the data during hot path, they enable consumption, primarily used for device provisioning. So what does API stand for, right? It stands for application programming interface. So some people are saying B. Or C. Okay. Okay, fine. So I'll like the answer. So the answer is C. They enable consumption by applications. Right? So if you have an application and you wanted to communicate with the resource, right? So the way it communicates with that is through an API, application programming interface. So it doesn't enhance the data during the hot path processing because it's only after hot path processing that consumption can happen, right? So that is when the APIs become most relevant. And of course, by that we also eliminate cold path processing, and device provisioning also is not its primary use. Now we go to the second lecture, time and clock synchronization in IoT. So why do Internet of Things devices in wirelessly connected mesh networks require mutual clock time synchronization? Is it to enhance device aesthetics, battery life, enable chronological ordering of sensor events, or to boost network speed?
I think the answer is C, to enable synchronical ordering of sensor events.
Yeah, that is true. So to enable chronological ordering of sensing events. So if the events in the IoT devices, they are not synchronized, the clocks are not synchronized, the processes clocks are not synchronized properly, then you will have the problem of correctness and fairness that we had discussed. And of course, network speed, battery life, these are very specific. We don't know how they are related to processes, and device aesthetics is definitely, of course, not the right answer, unless you consider correctness and fairness some sort of aesthetics thing, which is somewhat subjective. So it is not true. What challenges can be addressed by implementing mutual clock time synchronization in IoT devices in mesh networks? Is it increasing device weight, network aesthetics, coordination of asynchronous processes, reducing network load? Yes, so see, coordination of, sorry?
Yeah, the answer is C, coordination of asynchronous processes.
Yes, so that is the correct answer. So the coordination of asynchronous processes will be handled if you synchronize the IoT devices and the clocks and everything. So other three are wrong. So in a distributed system, how is the relationship between time at different locations described? Is it A, clear and well defined, B, unclear and ambiguous, C, non-existent, is it D, constant and synchronized?
I think D, constant and synchronized.
Okay. I want you to keep some keywords in mind. Time at different locations.
And ambiguous.
Okay. Any other responses? Are there any other responses? Okay. Fine. So there's a confusion between B and D. Okay. So if let's say you have two different clocks, right? On two different processes, and see there is no if there are different locations, means let's say they're on different devices, let's say, so both of them will have their own clocks, right? So in that sense, there is no guarantee that their clocks are running at the same time, or their clocks are running at different times, or there's no guarantee. We don't know how much difference is there in the timings. We don't know the difference in the clock frequencies of both the devices, right? So so in that sense, we can say that it is unclear and ambiguous, right? So there is another situation where it might be constant and synchronized. We'll look at that. And clear and well defined is not the most accurate answer because we don't really know what the meaning of clear and well defined exactly is in this case, and non-existent. See, there may be some relation, okay, between the two timings, but we don't know what that is. So how is the relationship between time at a single location described? Is it A, clear and well defined, B, unclear and ambiguous, C, non-existent, or D, constant and synchronized?
Constant.
Okay. Any other responses?
But is it meaning that in a single location there are many devices some distance apart?
Oh, no. I mean, like, when a single location, I mean, like, one device. Like
Then
inside.
it's clear and well defined also. What is that meaning?
So, clear and well defined could, as in, like, see, they,
See, if it's only one device, synchronized to what? It doesn't make sense actually. It should mean synchronized to UTC. You mean?
yeah.
You know.
Like, we could say that the clocks are synchronized, like, there could be internal synchronization as well, right?
Option D, sir.
Wait, so, okay,
As in,
let me give you
more than one process then.
No, see, let's say you have one device, it has 5 processors.
Okay.
Right, so each of these processors has some kind of relationship, right? There's some clock, let's say, is operating on some clock.
Usually the clock in an embedded system, say for example, is driven by a single UTC, crystal oscillator. So
yeah, but
then it's constant and synchronous.
But let's say I have a server with 5 processors in it.
Okay.
Okay, so each of these processors will have a clock associated with it, right? So what would be the relationship between the clocks of each of the processors? So that's what I want to. That is what I'm asking. If that is.
So it's a single server, but different processors. You mean?
Yeah, within one device. Yeah.
Still there will be some latency to some extent, right? Whenever there is a message passing or synchronization activity between the two processes.
I think the answer would be D, constant and synchronized.
Wait, just a second. There could be, but we would have to go into they have a common clock, right? That all of these processes are going.
Do they have a common clock? Then it's fine. Yeah.
Okay. Yeah. So each processor need not necessarily have a. See, for example, okay, So let's say you have let's say you bought a device, right? Let's say a MacBook or an Apple. So what do they say? It is 2.7 gigahertz, right?
Yeah.
So does that imply that there are 5 clocks or 1 clock in the system?
Then the word synchronized doesn't make sense from D, because synchronized to what? It is running by itself.
No, but each of those processes will have some sort of clock to refer to, right? Will keep some sort of time. So all of those time will likely be synchronized to some clock in that entire architecture. So okay, so Harun, once again, I could be wrong. If you have some other evidence, you could probably Google on the internet. If you post it on the forum, and if you find something that contradicts what I said, like I would be very happy to respond to that. Okay.
Yeah, fine.
So, so someone said, Rajesh Kumar said D, constant and synchronized.
I also have the same answer, D, because the clock has somewhere related to the server. It takes, the clock synchronized with the time server, right? And then it gets the constant time. So I am relating to that.
Okay, fine, fine. That's also a way to think about it. But I was kind of very specifically thinking of a single device actually. But okay, fine. So, what characterizes the model of processes in internet-based systems? Is it synchronous, asynchronous, parallel, deterministic? Okay, so it's asynchronous. Yes, that is the correct answer because in internet-based systems, you could have one device in one country, another device in another country. There is no guarantee that their clocks are perfectly synchronized. So, of course, parallel processes also could happen, but we are looking at it from the perspective of time. I should have mentioned that. Okay, of course, processes that are asynchronous can happen in parallel as well. Deterministic, there's no guarantee. In an asynchronous model for internet-based systems, what is the characteristic regarding message delays? Asynchronous, keep this in mind. Well-defined and minimal, no bounds, synchronized and predictable.
Are they following some protocol like whatever that DTP, NTP, I think so something was taught. So if they are following, then uh, it was written bounds within RTT. Means
That is
round.
for Christians, yeah, yeah.
Yes,
No, no, no. Let's assume that nothing is being followed.
then no bounds.
Yeah, that's the right answer. No bounds. Any other responses? Yeah, so if you are in Christian's algorithm, then it is no bounds. If you are in if you are in Christian's algorithm, then you have that RTT minus min minus mid. Some you have some one expression for the bound. If you're in
So
NDP, then it is round trip time. Yeah.
I had a question like RTT can also be unbounded, right? Or means I felt it's saying bounded as a function of RTT, but can RTT become unbounded? Then the entire thing doesn't hold.
Um, well, you could technically say that RTT can be unbounded, but RTT is a function of the two processes, right?
RTT is basically function of the transmission delay and the between one message sent from one processor at one corner of the world to the other corner of the world, say another process, and then coming back time.
Yeah, yeah, that is true. But see, like RTT itself may not be bounded, but it is predictable, right? It is not like it is some random number somewhere. Right? So we can say that.
See, RTT can be a random variable. I mean, it basically.
Yes, but it is not like absolutely random, right?
No, not absolutely random. It has some characteristics like mean, median. Some statistics will be there.
Yeah.
It depends upon the traffic that time and also the receivers.
Yes, so like within some probabilities, you could say. See, so okay, so let's say the RTT it follows, let's say some sort of Gaussian, right? So in that sense, if you want to say what is the probability that the RTT is, let's say between two IoT devices that are placed very close to each other. Okay, between let's say
we with some standard deviation within the standard deviation, say within one or two standard deviation for Gaussian, I think so 95% chance of coming within this range.
Yeah. So within a reasonable probability, right? We can say it is bounded. Yeah. So let's say you have so in the real world, let's say with 0.00001%, we can say that the RTT is 1 hour, but with let's say 95%, we can say that the RTT remains between let's say some reasonable limit like 3 to 4 seconds. So we can say that there is some amount of predictability to it. So it is not truly unbounded. Of course, if you look at it from a very pedantic sense, you could say it is unbounded, right? But practically speaking, it is practically, you could say it is not truly,
Yeah,
bounded.
yeah.
Oh wait, have we discussed? Okay, no bounds. I hope it is clear. So, what is a characteristic shared by a multiprocessor systems that differ from the asynchronous model in? Uh, let's just skip over. I think I want to discuss some other things. I'll make these slides available to you. Okay.
Oh, where was the last week's slide and answer key?
It
Where
was. It is there. It is in the forum. It is not in the forum. In the announcements, it is shared actually.
Okay, as in to everyone's email.
No. Like if you go to the course page, right? If you go into the
Yeah.
announcements, there's a link to a sheet. Okay. In that sheet, there is a
Okay.
link to the recording.
Okay, announcements tab. Okay.
Yeah. There's a link to the YouTube video and the recording.
And where is the
Yeah.
not the recording? I meant your PPT. Where
PPT is also there. Yeah. PPT link to the PPT is also there in that. You can check.
Okay.
If you want, I will.
Yeah, if you could share.
Now I can't share. I need to put it in one folder and then share. Okay.
Let me just check.
Wait. If you just go to the cloud announcements page. Okay.
Yeah. I went to cloud announcements page. Now for week 2 feedback, then week 2 content is live now. So this is okay. Foundation problem solving session, and there is only link to it.
Yeah, just click that link. There's a Excel sheet. In that Excel sheet, both are there, recording and the.
So there is only link to join. This is problem solving session for
Okay,
F24.
I'll do one thing. Let me do one thing. I will. Can I make
No,
this?
there is no such problem solving session. There is only feedback. There is no.
Just a second. I'll make this. I'll send a link to the sheet to you. Okay. Just you can refer to this. Okay.
Okay.
So this sheet contains whatever links are required for every week.
Okay.
What does an event represent? Occurrence of an action. Okay, I want to discuss some numerical. Okay, these are relatively easy MCQs. I will make it available to you. Okay, so Christian's. So did everyone understand the Christian's algorithm for clock synchronization? Or would you? If you want, I can go through a very short numerical. Okay.
Yeah,
Okay.
please go slow. Go slow.
Okay, fine. So over here I have a client and a. Wait, so is my pointer visible? See.
No. Yeah.
Okay, fine. So over here I have a client and a server, and I want both of these to, let's say, synchronize to this this big one, to this big universal time keeping clock. So what I will do is, first I'll make note of the timestamps of both of these clocks. So the first one, not of both of these clocks, of this first clock, I'll make note of it as T0. So T0 equals 10:25:10. After that, I will send a request. Okay, and I will send a request to this server, and after that I will get the response. After that, I will calculate the round trip time, okay, of this entire example from T1 minus T0, and T1 is the time when I have received this when I have received the response from the server. I will calculate the round trip time as T1 minus T0, and over here it is 4 seconds. And then after that, what I will do is I want to figure out what is the correct time that I should be keeping over here. So delay time in sending a reply uh, I want to take the halfway point between here, because if I because after it has sent the request, right, some time would have sorry, after it has, like, it would make a note of that time, right? After it has sent a response, this 10 25 13 would have changed a little bit.
Yeah, correct. So the client means both the right hand left hand clock are the same clock, same physical.
Yeah. Client, yes, both of these are the same physical clock.
Yeah. So you're getting one-sided time and then adding that time to that response bucket, response clock of the UTC, and adding that, so
Yes.
that after receiving it you are synchronized to the UTC.
Yes.
Approximately synchronized.
Yes, I only want to add the halfway time from here, because only the halfway time would have moved from here. This is the simplest algorithm. So over here 4 seconds have passed, divide by 2, you get 2 seconds, you add 2 seconds, you get 10 25 15. Okay, so this is Christian's algorithm. This is very simple. Now we'll go into network time protocol offset calculation. So now this offset, actually it has arrived from solving two linear equations. Okay, so the offset formula that you get here, it has arrived from solving two linear equations that have been mentioned in the slides. So for shortage of time I cannot go into that kind of detail right now, but it has been the derivation of this offset formula has been mentioned. So generally what has been done, this has not been discussed in the slides. When you calculate this offset, right, this is actually added to this T4.
This is the 2 second in the previous example.
Huh?
This is the 2 second addition offset.
No. This is different. This is you're dividing the round trip time by 2.
This is also round trip time, right? Client go request response. This minus this minus this. You are adding basically T2 minus T1 one-sided plus T4 minus. Oh, this is T4 minus something.
Yeah, that would be T4 minus T1 is the round trip time.
No. Oh, okay.
Okay. T4 minus T1 is the round trip time. Over here, I'm just adding up the latencies.
Acha, these clocks are two different clocks, right? If
No.
clients
Same clocks. See.
So at 1100, if I send, T2 should be more than that, right? Is it like because two clocks are different at client and server?
Listen. Once. See, T1, T4, same clock. T2,
T1,
T3,
T4, same clock. T2, T3, same clock. Achha.
But T2, T1 is different clock. T3, T4 is different clock.
Yeah.
Okay. So that is why this, see, there's no relationship between this T2 and T1. Okay. Yet. There's no relationship yet. So what is happening over here is, we're first doing T2 minus T1. So this will give us the latency between T2 and T1. Then we're subtracting the latency between T4 and T3. But we write that as the addition of T3 minus T4. Right? So that will give me some latency. After I add that up and I divide by 2, the derivation of this formula, you can see search slides. It is the same formula I have verified. Okay. So after you do that derivation, you get minus 325. This is added to T4. Okay. This is added to T4 to get the synchronized time in the network time protocol offset calculation. Now let's look at the Berkeley model. So similar formula is actually there in search slides also. It's actually the same thing, but this will be a little more clearer to you. Okay. So in the Berkeley formula, what we did was we wanted to average out the fault tolerant the difference between the fault tolerant clocks and the main server. Then after that we wanted to average it out. Okay, and then after that we wanted to take that time and send offsets to each of the various slaves. Right? Okay. So over here, so first of all we make note of the times that are over here. Over here it is 10:25:13, 10:25:23, 10:25:43. Then at TM we have 10:25:33. Okay, and by the way, I've taken these from YouTube videos. You can refer to the YouTube videos in the links over here. So first of all, what we do is we calculate the difference between this TS1 and TM, it's minus 20. Again TS2 and TM, again minus 10. 43 and 33, again you get minus 10, plus 10, and the server difference between itself, it is 0. I have some problem with the example that sir has given in his slide, but I think this is more accurate answer. Okay, so what you do after you calculate all these differences is you add them up and you average it, so you get minus 5 seconds. So then what you do is after you get this minus 5 seconds, now you're going to take this minus 5 and add it to the server's time, right? You add this minus 5 to the server's time and you get a certain answer. You get 10, 25, 28. Now you have to readjust each of the clock's timings to meet the server's time, okay, in the Berkeley's algorithm.
Can you go to previous slide one?
Yes.
Okay, so you made minus 5, okay, to the server. Okay.
Okay, so this is another way of thinking about. So what has happened in search slide is search again TM, TS1, TS2, TS3. He has added these up and he has averaged it out by 4, but and that will give you the time at the server. But what we have done over here is we have taken the difference between this TS and TM between all of these and divided it all by 4. So you will get the same formula as the one that sir has discussed in his slides over here. But over here, the understanding this one is a little bit more intuitive, and also that when we had discussed in the slides, right, that sir had discussed that we want to that the main idea is that if we average out the differences, the hope is that the time will be synchronized, okay, across all the clocks.
So this is synchronization within the 4 clocks, right? But it's not any external synchronization.
No,
right?
no. This is not external.
This is internal only.
Yeah. So external would be if
okay, you are basically setting everything to 10, 25, 28 basically by calculating.
Wait. Actually, that depends on the details, right? So this server you could say that this has the most accurate time.
Yeah, but they are actually averaging out, giving equal weightage to all.
Yeah. Okay. So yes, that is right. So this is like for internal synchronization. If I'm not wrong. Like, but if you look at NTP or something, that is the perfect, like the root node, right? That has the perfect time, stratum 0.
Mm-hmm.
Okay.
That gets synchronized with UTC.
Yeah. So that will get synchronized with like UTC. You can cross check this also once for me. But if you ask me, I think this is internal synchronization because
this is internal because because you're even changing the master one. That means it's not the reference.
And also you can choose any of the nodes actually as the master. That is also one more thing. You can choose any of the nodes as the master, and you can after that connect, and also one of the nodes can drop out also. That possibility is also there. Okay. So in that sense, that is how the Berkeley's algorithm is calculated. Okay, so I think we can do some more questions. I think we had missed out some questions because I wanted to discuss the numericals. I'll just take like 5 more minutes. If you all want to stay, you can stay. I'll be here till 5:10. Okay, so I think we stopped over here. Okay, so which feature allows events within a process to be ordered linearly in an asynchronous distributed system? Oh no, wait, let's go to the next one. Okay, I think, yeah. Okay, let's start with this one. So how does a non-zero clock drift affect clock skew over time? As it A, it decreases clock skew, it eliminates clock skew, it causes clock skew to increase, or D, it has no impact on clock skew?
It causes clock skew to increase, but no guarantee initially it will increase. Initially it may decrease and then finally.
Why will it decrease?
So basically if your current clock is 3 AM, say another clock is 4 a.m. and 3 a.m. is faster than the 4, then slowly the difference will reduce and then finally start increasing.
Yeah, right. Okay, that makes sense. Okay, so if let's say they were, let's say, perfectly synchronized, but then after that you can say that if they have drift, then it will increase.
Yeah.
Yeah, but if that is right, that is a good point you have mentioned. Okay, to what standard are physical clocks synchronized for accuracy in a distributed system? A. Local time. B.
Universal coordinated time.
Ha. Yes, that is the correct answer. What is the criterion for a timer to be considered working within its specification? Is it A. Constant synchronization, B. Maximum clock skew rate, asynchronous behavior, or D. Clock inaccuracy?
Max clock skew, it's always not with drift, it's the distance.
Yes, you're right, you're right. So the maximum clock skew rate is actually the specification that is used. I think you must have seen the DC over DT plots, and DC over DT less than 1 greater than 1 0. It is in that context that we use this maximum clock skew rate, and the of course, and the others aren't even criteria. So in terms of clocks synchronization, what does adherence to UTC ensure for physical clocks? Is it absolute time synchronization, elimination of clock skew, maximum clock drift, or synchronization with local time? So, okay, so I think so. So yes, so A would be the most accurate answer. Obviously, if all of them are coordinated or adhere to UTC, that would indirectly also eliminate clock skew, right? And we cannot say anything about the drift, right? Because there's a possibility that the clocks may drift in the future. That the skew may increase because of the drift in the future. So C is the wrong answer. So synchronization with local time is also you could say, but the main idea is A, absolute time synchronization. Oh, I'm sorry. I think D is the right answer. Sorry. Synchronization with local time is the right answer. I mean D, A, and B you could say. What is the relationship between internal synchronization and external synchronization in a distributed system? Is it A, they are synonymous, B, internal synchronization implies external synchronization, C, external synchronization implies internal, or D, internal synchronization does not imply external synchronization? Can you answer?
Option C.
Okay.
D.
C and D. So yes, so C and D. So if two clocks are externally synchronized, right? So they are synchronized to some external clock, right? So that means they are internally synchronized to each other internally, right? Because they have the same time. But if two clocks are synchronized internally, then both of these may have totally gone away from the external system. So that is why internal synchronization does not imply external synchronization, right? So because of that, B is the wrong answer, and D, internal synchronization does not imply external synchronization, is the right answer. Okay, I think we're at the end. If you all have any questions or something you want to ask. Please let me know if you have any questions. And I would have liked to discuss vector timestamping also. Does anyone have any doubts or questions? Okay, fine. Let's see if there's anything we've missed. Maybe. Yeah, I will send the question and answer file. Sure. It is in the sheet, by the way. Okay, let's look at this 66 also. I think we didn't look at this. What feature allows events within a process to be ordered linearly in an asynchronous distributed system? Is it A, synchronized clocks, B, event timestamps, C, Google global clock, D, fixed time intervals? Okay, so the answer is B, event timestamps. Okay, fine. So okay, so I think with this we can conclude this session. Thank you everybody for coming, and I hope to see you all in the future sessions. Please leave your feedback, and if there's something to improve on, please let me know. I will end the session at this point.